Yesterday, we worked on solving problems with percent. And yesterday, our main focus was figuring out whether a problem was one of two types of problems we've studied, whether it required us to convert fractions to percents, or whether it asked us to find the percent of a quantity. Today, we're going to look at problems that are a little bit more complex. In these problems, we'll be looking for the percent of a quantity, but we might need to use two steps in order to find our answer, meaning that some of the information we need is going to be missing when we begin the problem. So first we'll find missing information, and after that we'll look to solve the problem. Every time we're going to use the UPAC method. We started that a bit yesterday by just clarifying what is it that we already know and what is it that we're looking for before we start any mathematical operations. Okay, it does you absolutely no good to flash look at a problem and start multiplying out of nowhere. We really need to understand what we know and what we don't know before we can take action. So let's get started. And for the first few problems, I'm really going to delineate how we're using the UPAC method. But as you notice the pattern, I will have that move along and get a little shorter. In this first problem, there were 400 members in a swimming club. 12% of the members were children, the rest were adults. How many adults were there? So in our bar model, we can see that we're working on understanding the problem. We have the total quantity, 400 members. We know the partial percent, 12% were children. But we don't know the part we're looking for. We're looking for the quantity of adults, but we don't yet know the percent, the partial percent that were adults, nor do we know the quantity that were children or the quantity that were adults. So there's a lot of missing information in this problem. I do want to make sure that you know there's multiple ways to approach the problem. So I'll just show you one way, but then I'll mention another way you could have approached it. So first we can find out how many children there were using percent of a quantity. And then we can subtract the number of children from the total number of people in the swimming club to understand the number of adults. That way, we'll figure out some missing information, we'll use subtraction to help us find the next quantity, and we'll end up with the answer we need, which is the actual countable number of adults in the swimming club. Let's try that. So there were 12% of the members were children. We need to find 12% of 400. So remember, we're doing 12 over 100 multiplied by 400. The 400 and the 100 cancel out, so we're really just doing 12 times 4. That gives us 48. 48 of the members were children. Now we're going to take that total quantity, 400. We're going to subtract away the children, 48, and that will help us find the number of adults we actually have. So in this case, you should have gotten 352 adults. There's another way we could have solved this. Back when we looked at this, bar model, we decided to find the number of children first. But we could have decided to find the percent of adults first, and then use percent of a quantity to find the number of adults. If 12% of the members were children, then we know 88% of the members were adults. We know this because the total percentage is always 100. Remember, percent means out of 100. So we could have found 88% of 400, and that would have given us our number of adults. Now, this first method, I would say, is better because you are multiplying numbers that are smaller, which means you have less likelihood of making mistakes in your multiplication. All right, we've understood through a bar model. We planned by figuring out how we were going to fill in missing information and what result it would give us. We worked through the fraction multiplication and the subtraction to get an answer, and then we checked to make sure it made sense. In our bar model, we can see that there were way more adults than children. So it's good that our number of adults, 352, was smaller than the total, which is 400, and way bigger than the number of children. This answer makes sense. Let's try another two-step problem with percents. 150 students took an English test. 98% of them passed the test. How many students did not pass the test? So in this case, we're looking at a bar model where the total number of students is 150. We have the shaded region, 98%, almost all of them pass the test, but we're looking for the tiny sliver. How many students did not pass the test? Similar to last time, we can find the number of students who passed the test and subtract that from the total, or we can find the percent of students that did not pass the test and use percent of a quantity to figure out how many students that actually was. Either way, we need to do 2 steps. So I'll show you one method and then explain the other method. We've already done understand, we've done plan. Now let's take action to answer. 98% of 150, okay, 98% of 150 is 147 students. We got that by multiplying 98 hundredths times 150. 147 students passed the test, so I can subtract that from the total number of students, 150, and that gives me the number of students who failed the test. Another thing I could have done was find 2% of 150, because that is the percentage of students that failed the test. I know that because 100 minus 98 gives me 2%. So that tiny sliver of students is 2%. Then when I found that, I would figure out that 3 students failed the test. Either way, you get the same answer. So it doesn't matter which method you choose. You need to choose the method that's best for you. But always step back and understand the problem with a bar model before you start multiplying. Let's look at another problem, and this time we're going to talk about the concept of discounts. Discounts is a real-life situation in which we use percent of a quantity and a 2-step method with percents. When we get a discount on something, it's the amount of money we save when buying something. So you've probably walked into a store and seen shoes 20% off. Okay, so when we have a discount of 20%, we're saving 20% of the original cost. We're only paying 80% of the cost. Mr. Jackson bought a refrigerator at a discount of 12%. The usual price was $900. How much did he pay for the refrigerator? We know he paid 12% less than $900 because the refrigerator was on sale. Normally, it would have cost $900, but it's going to be cheaper because of a discount. So first, let's figure out how much that discount was worth. We need to find 12% of 900. We find that by multiplying 12 hundredths times 900, and we get $108. So the refrigerator was $108 cheaper than it normally was. Now we need to take the total normal price and subtract the discount. 900 minus 108. That's going to give us the selling price that Mr. Jackson actually paid, which is $792. Remember, whenever you're asked about a discount, you need to listen and think to yourself, do you need to find the amount of money that the discount was worth? Are you looking for the amount of money the person actually paid? Or are you looking for the original price? Once you know what you're looking for, you can use our equation right there. Discount minus usual price gives us selling price to help you reason through how much the person actually paid or whatever other figure you're looking for. Let's look at another discount problem. The usual price of a pair of shoes was $45. It was sold at a discount of 20%. Find the selling price of the pair of shoes. So this time we're looking for the selling price, but what we don't know is the actual dollar value of the discount. We need to find 20% of $45 because 20% is how much that person saved. So first we're going to find 20%, which is 20 over 100 times 45. That gives us $9. So we subtract that discount from the actual total price of the shoe, and we can find out how much someone paid for it. So 45 minus $9 gives us $36. So the shoes were 45, and now they're cheaper. They're only 36. Whenever you're doing a discount problem and you're looking for the selling price, make sure that selling price is lower than the original price. Otherwise, that's not much of a discount. I'm going to split this video into 2 parts. So please come back to see the next 2 parts of our discount problems we're going to look at some bar models that are a little bit more complicated, where we have 3 different parts as opposed to just 2 parts in our whole. All right, keep checking it out.